Hi students, welcome to Easy Chemistry by Patan, and today we are going to discuss an important concept in electrochemistry, that is commercial cells or batteries. In that primary cells, secondary cells we discussed in last class, and here today we are going to discuss a secondary cell, that is a fuel cell, hydrogen oxygen fuel cell. Hydrogen oxygen fuel cell is a secondary cell. Secondary cell. Hydrogen oxygen fuel cell is a secondary cell. Means we can use again and again. Means discharging, charging, both are takes place in this. What is the main concept in this? Means here the main concept is the heat of combustion. The heat of combustion. Heat of combustion is directly heat of combustion is directly converted to electrical energy. This is the main concept of oxygen hydrogen fuel cell. The heat of combustion is directly converted to electrical energy. What is heat of combustion? For example, if a fuel is subjected to heat and this release some heat, this will release some heat. This heat is converted to electrical energy. That is, we are calling heat of combustion. Means combustion nothing but burning. When we burn any fuel, it releases heat energy. That heat energy is converted to electrical energy directly. Clear? For that, here the fuels we are using gaseous fuels, that is hydrogen and oxygen. That's why this cell is called as hydrogen oxygen fuel cell. The fuels, especially gaseous fuels like hydrogen and oxygen, we are burning here. We have liquid fuel cells also. That's why that is different again. Here we are using only gases, that is hydrogen and oxygen. Look here how this will be operate to generate electrical energy. Clear? The arrangement of this. Here I am drawing a rough diagram for oxygen and hydrogen fuel cell, and this is the cell we have here, and it contains two parts. And this is we have here an H2O2 chamber, H2O chamber. From here, what will be released? H2O in the form of gas. And here we have one is anode and another is cathode. And this act as cathode positive, and this act as anode negative. Clear? And this is we have one inlet from we are passing hydrogen gas, and here we have another inlet, we are passing oxygen gas, and these two are here going to be burned and releasing H2O2 in the form of gaseous form, means vapors. These vapors later converted into electrical energy. This is the construction we have. What happened in the reaction, let me discuss. See here, hydrogen gas is bubbled through electrolyte. This hydrogen gas bubbled through electrolyte. Clear? When hydrogen gas is bubbled through electrolyte at anode, this is anode. At anode here negative. Undergo oxidation. Hydrogen undergo oxidation. Similarly, oxygen gas is bubbled through electrolyte. Clear? At cathode. Cathode means here positive. And this oxygen undergo reduction. It is clear now? A redox reaction now. Hydrogen undergo oxidation at anode. Oxygen undergo reduction at cathode. Clear? And porous graphite rods are there here. Porous graphite rods also. These porous graphite rods also we are arranging here. These act as electrodes. Positive electrode, negative electrode is there now. These porous graphite, positive and negative. And these graphite rods are coated with platinum or silver. Graphite rods are coated by platinum or silver, even with CaO also, which act as catalyst. Clear? These are act as catalyst. So platinum, silver or CaO act as here catalyst. So graphite rods act as electrodes. These electrodes are coated with platinum, silver or calcium oxide also. And what is the duty of these three means? They act as catalyst. So this is construction of H2O2 oxygen, that is hydrogen oxygen fuel cell. So these two are graphite rods, electrodes coated with platinum, silver or calcium oxide as act as catalyst, and two inlets are present. One is bubbled out hydrogen, another oxygen. Where hydrogen is bubbling, that is anode oxidation. Where oxygen is bubbled out, and that is cathode positive. So hydrogen undergo oxidation at anode and oxygen undergo reduction at cathode. Now we have to discuss cell reaction. This is very important. Cell reactions in primary or secondary, very important. That cell reactions I am explaining to you. Reaction at anode first. I am giving at anode. Anode means, already I told, at anode hydrogen undergo oxidation. Oxidation means loss of electrons, or so many definitions we have. So hydrogen gas react with OH minus ions and giving water molecule. What it will give? Water molecule, which release 2 electrons. Clear? This is we are calling oxidation. Hydrogen react with OH and undergo water, means H2 converted to H2O. This is we are calling oxidation. Now at cathode, cathode what I given here, at cathode oxygen undergo reduction, means loss of oxygen. So this oxygen molecule react with water molecules, by taking electrons, especially 4 electrons, and undergo reduction as OH minus. This is in aqueous position. So this we got minus 4 electrons, means here 4 electrons it is taking, here electrons releasing, loss of electron, here electrons it is taking. So 4 OH minus. So 4 OH minus. So at anode oxidation, at cathode reduction. So this is oxidation, already I given, and this is reduction. At anode always oxidation, at cathode always reduction will be takes place. Now you write overall reaction. What we are writing? Overall reaction. Overall reaction, that is cell reaction, means we have to combine oxidation and reduction. So here hydrogen and here oxygen, giving rise to water molecule. This is overall cell reaction of oxygen hydrogen fuel cell. Very easy. See here we have fuel cell, that is secondary cells, whether they may be gaseous fuel cell or liquid fuel cells also we have. Hydrogen oxygen fuel cell we are discussing here. It is a secondary cell. Here fuels we are using hydrogen gas and oxygen gas. That's why hydrogen oxygen fuel cell we are calling. The main concept of this fuel cell is the heat of combustion is directly converted to electrical energy. When you burn a fuel, whether gas, liquid, whatever it may be, and then heat energy will be evolved. This is we are calling combustion heat. This will be converted to directly electrical energy. Fuels, if gases we are taking here, H2O2, that's why H2O2 fuel cell we are calling. And this is the arrangement. It is the cell, 2 chambers are there. One side oxygen is bubble out, one side hydrogen is bubble out. Hydrogen at anode, oxygen at cathode. Clear? And here we have 2 electrodes made with graphite. These graphite rods act as electrodes, and moreover these are coated with platinum, silver or CaO. This platinum, silver or CaO act as catalyst for betterment of the reaction. Hydrogen, when we bubble out at anode, hydrogen undergo oxidation. At anode always oxidation will be takes place. And oxygen we are passing through electrolyte towards cathode, and this oxygen undergo reduction at cathode. Now I told already this is porous. Graphite rod cold. And cell reactions. At anode, hydrogen gas taking OH minus ions and converted into water. Oxidation. At cathode, oxygen react with water, undergo reduction to OH minus. This is reduction. Overall reaction, hydrogen plus oxygen giving rise to water molecule which is in liquid position. So what is the use of this fuel cells? Means these are 100% efficient. 100% efficient. We can use again and again. That's why this is a secondary cell, where you go for Leclanche cell, for example, dry cell. Once we use it, after a period of time, that is going to be dead. Again, we can't reuse. But secondary cells, they have the efficiency to use again and again. Cell efficiency. Cell efficiency, we have the formula also. Efficiency of fuel cell. Efficiency of fuel cells can be calculated by using delta G naught upon delta H naught. You know very well, Gibbs free energy G, H is enthalpy. Change in Gibbs free energy upon change in enthalpy at standard condition. Not I given na, at standard condition. And this is the formula we have to calculate efficiency of fuel cell. And this is the information about hydrogen oxygen fuel cell. We have hydrocarbon oxygen fuel cell also. Not only hydrogen oxygen fuel cell. Hydrocarbon oxygen fuel cell means hydrocarbon and oxygen are going to be burned and combustion reaction will be takes place, and in that heat energy will be evolved. That heat energy directly converted into electrical energy. So not only hydrogen oxygen, hydrocarbon oxygen fuel cells also we have. Liquid fuel cells like methanol, ethanol, when we burn and you are getting the heat of combustion, that heat of combustion is going to be converted into electrical energy. That we are calling liquid fuel cell. If gas is used, gas is fuel cell. If liquids are used as fuels, that is liquid fuel cells. Liquid fuel cells we don't have in our syllabus. We have only gases fuel cell, especially hydrogen oxygen fuel cell. And here the main concept is cell reaction. See, hydrogen undergo oxidation at anode, oxygen undergo reduction at cathode. So at anode, hydrogen undergo oxidation to water. At cathode, oxidation here, anode. At cathode, oxygen undergo reduction to OH minus. OH minus. See this water, lossing of electrons are gaining. Loss of electron, gain of electron. That also you can remember. So always anode, oxidation, cathode, reduction. These are electrolytic cells now. Anode is negative, cathode is positive. Generally anode is positive, cathode is negative. But here in electrolytic cells, reverse we have to take. Why? Because here electrons are releasing. At anode, electrons are releasing. When electrons are released, anode get negative charge. These electrons moving to cathode, towards cathode, where here we have the positive charge. So in electrolytic cells, anode negative, cathode is positive. Normally anode is positive, cathode is negative. This is about hydrogen oxygen fuel cells. Thank you.